अभी तक आए नहीं है एक बार में। तो आपका थोड़ा सा हार्ड वर्क ज़्यादा हो जाएगा, लेकिन भी करना पड़ेगा स्टूडेंट्स को।
अच्छा कर लेंगे।
आज सिद्धार्थ मौर्य आया क्या?
कुछ इवैल्यूएशन भी करना है।
हाँ सर, मैं देता हूँ। हाँ हेलो। हाँ ठीक है। ट्रैक 1 और 2। हाँ अच्छा अच्छा ठीक है।
टाइम से स्टार्ट करते हैं, काफी सारे
हाँ हाँ
कैंडिडेट हैं।
हाँ। जैसे ही सेशन ओवर होना होगा, जैसे लास्ट कैंडिडेट्स बाकी होंगे, एक बार आप आपके पास विकास सर का नंबर है? विकास नहीं, सौरभ सर, हाँ सौरभ सर के नंबर पे एक बार कॉल कर लीजिएगा। एक फोटो सेशन होगा और एक सर्टिफिकेशन सेशन होगा, तो उसके लिए तो अभी हम स्टार्ट कर सकते हैं।
अच्छा उसमें कैंडिडेट है क्या?
हाँ एक कैंडिडेट है।
एलिक्स।
हाँ
हेलो
हाँ
हेलो। हेलो 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 हेलो।
Good evening, sir.
गुड इवनिंग। हेलो।
Good evening, sir.
Okay, so we will start now. So welcome you all in the track 5. So we'll start with the first participants with paper ID 612. So I kindly request to the authors of paper ID 612 to present their PPT. And please follow the timelines. You have total 8 minutes, 5 minutes for the presentation and 3 minutes for the question answer.
Okay. Shall I share my screen, sir?
Yes, yes, you are audible.
Shall I share my
Shall I
screen,
share
sir?
my screen, sir? Yeah, yeah,
PPT.
please share your screen and you can start the presentation.
Yeah, sure.
Yeah,
Thank you,
sure.
sir.
Thank you, sir.
Is my screen
My
visible,
screen
sir?
visible. Yeah, we can see it. So you please start.
Yeah,
Yeah,
sure.
so
Good afternoon,
good
everyone.
afternoon,
Our
everyone.
paper
Our
is like
paper
a
is like
hybrid
a hybrid
multimodal famous
multi-model famous
transformer
transformer
CN framework
CN
for change
framework for
detection.
change detection.
Presented by
Presented
me,
by me,
Alexis, and
Alexis,
my
and
guide
my
Anita
guide
and Kalesh
Anita
Selvi
and
and my
Kalestevi and my
teammates. We
teammates.
are from
We are from
National
like
Engineering
National
College,
Engineering College,
Koilpatti.
Koilpatti.
First I explain why
Why
detecting plan
detecting
changes
plan
matters.
changes matters.
Then I talk
Then
about
I talk
existing
about existing
approaches and their
approaches and their
limitations.
limitations.
Then I
Then
explain our
I explain
proposed
our proposed
architecture
architecture
and our results
and our
and
results
conclusion.
and conclusion.
Yeah, start with the
Start with the
problems introduction
problems,
and problem
introduction
statement.
and problem
So we
statement.
can
So we can
get why
by
LOS and change
LOS
detection
change
matter.
detection matter.
Um, yeah, by
By
2050, like
2050,
68% of world
68% of world
population will live
population
in
will live in
cities,
cities,
which is the
which is
report
the
data
report data
provided by United
provided by
Nations.
United Nations.
This rapid
This rapid
urbanization
urbanization
destroys
destroys
forest,
forests,
farmland, and water
farmland, and
bodies.
water bodies.
We need to
We
monitor
need to
these
monitor
changes
these
for
changes
urban
for
planning,
urban planning,
disaster
disaster
management,
management,
and climate
and
studies.
climate studies.
But it's very
But it's
difficult
very difficult
because forest
because
and crops
forests
look
and crops
similar
look
in both
similar in
different
both
seasons.
different seasons.
To
To
identify this, we
identify
have
this, we have
developed this
developed
architecture
this
model to
architecture model
find
to
change
find
detection
change
between
detection
two
between two
time
time
periods.
periods.
Like, uh,
Like,
yeah,
yeah.
these are the
These
existing
are the
approaches
existing approaches
which we studied
which
and
we studied and
identified.
identified.
Um,
Um,
yeah, these are the
these are the
existing
existing
approaches.
approaches.
First one is
First one is like
uh,
uh,
the
the
first one is
first one
done
is
in
done
between
in between
2013 and
2013 and
2023. They have
2023.
used
They have
the
used the
classification
classification
algorithm
algorithm
using
using
Google Earth
Google
Engine.
Earth
The
Engine.
accuracy
The
have achieved
accuracy of actually
85%
80%
of seasonal
of
angle.
seasonal angle.
And
And
second one is
second one is
Tesfaye et al.
display at all.
They have
They have
used four
used four
algorithms:
algorithms,
random forest,
random
SVM,
forest,
and COT, and
SVM, and
another
code,
one.
and another one.
They have
They have
classified the
classified
forest
the
and
forest and
in
in
Ethiopian
Ethiopian
cities with achieved
cities
of
with achieved of
92.5 percentage.
92.5%.
Likewise, we
Likewise,
have
we
listed
have
four
listed four
director works.
director works.
Each one uses
Each one
each
uses each
algorithm, and we have
algorithm, and we
studied
have
that
studied that
thoroughly and
thoroughly and
identify the gaps
identify the
between
gaps
our
between
approaches
our
and
approaches
existing.
and
We'll start
we'll
with
start with
this is our
this is
proposed
our proposed
architecture.
architecture.
Yeah. Our
Our
architecture mainly
architecture
uses
mainly
two
uses two
algorithms. One is
algorithms. One is
this is the hybrid.
the hybrid.
We combine
We
CNN,
combine CNN,
CNN and
CNN, and
transformers, swing
transformers
transformers.
in transformers.
So it makes
So
our
it makes
models
our models
unique
unique
and achieve
and
better
achieve better
accuracy.
accuracy.
Our model
Our
consists
model
of four
consists of four
layers. First
layers.
one is
First one is
will
will
first one data
first one data
processing. We'll
processing.
just
We'll
get
just
the
get
satellite
the satellite
images and
images and
process into
process
our
into
pipeline
our
to
pipeline to
normalize.
normalize.
And second one
And
is the
second
main
one is the
core
main core
architecture,
architecture,
like
like
our CNN
our
and
CNN
transformer
and
encoder,
transformer encoder,
which you can
which
see
you
in
can
the
see in
image.
the
Like
image.
first we take the
First we
input
take the
and
input
then we
and then we
pass that
pass
into our
that into our
architecture,
architecture.
and then we
And
do
then we
cross
do
temporal
cross-temporal
processing,
processing.
and then
And then
we
the
first we do
first we
encode
do
and then
encode and then
decode, and finally
decode.
we
And
get the
finally we
change
get the
map what
change
has
map
been
what
changed
has been
between
changed
two
between
different
two different
timelines.
timelines.
This is our entire
This is our
architecture.
entire
I
architecture.
explain one
I
by one.
explain one by one.
First what we
First
do,
what we do,
we getting
we getting
bitemporal images. Bitemporal images
bitemporal
means
images
we'll
means
get
we'll get
two time period
two time
images.
period
For
images.
example,
For example,
2013 image
2013
and
image and
2023 image.
2023 image.
We we feed
We
that to the
feed that to
algorithm
the
to find
algorithm to
what
find
change has
what
been
change has
actually
been
occurred.
actually occurred.
This is helpful
This
for
is helpful for
finding for urban
finding for
planning and
urban
research.
planning and research.
First,
First,
our data
our
pre-processing
data
algorithm will
pre-processing
first
algorithm
do
will
step
first
one
do
is
step one is
normalization.
normal.
Like uh, For example, T1 and T2 image were taken in different seasons, different times of a day, different atmospheric conditions. Their brightness may differ. To match that, we applying volumetric normalization, so it will look same. So the brightness will not consider as changed. To prevent this, we are applying volumetric normalization. And second one is image co-registration. This ensures that each pixel in T1 and each pixel in T2 are not misaligned. Like it will um, like the subpixel accuracy means like alignment error is less than 1 pixel. So it will ensure like there is no misalignment within pixels. And third one is like resizing and normalization. To feed to our algorithm, we are using 256 into 256 pixels, and three is like RGB. Likewise with standardizing. And then data augmentation is like to reduce overfitting, we just do some random rotations and fittings to fit into the to prevent overfitting. This is the data pre-processing we do for the satellite images, for two bitemporal images, satellite images. And the data set we use here is like liver city data set. This is like most popular in Kaggle. Like it consists of 637 bitemporal resolution, which taken from Google Earth Engine satellite. And then yeah, it mostly consists of building images for between time period of 2010 and 2020. We are using this, we have classified this. And yeah, now the main core architecture we enter like first is like data pre-processing, second is encoding. Like yeah, I explain this how this encoder works. Why we choose like CMS encoders, like because like CMS work on two different batches with same shared network. So it suits our use cases because we have T1 and T2 time period images. To make it more efficiently, we have choose CMS encoder. How it works like two branches, one set of bits. T1 goes into branch 1 and T2 goes into branch 2. Both branches are literally the same network. So like it's easy to extract fine local special features by using CNN, and transformers will capture global dependencies between distant regions. So this is how this encoding works. It is passes into four stages. The stage one is like um, it's the 4 into 4 conventional CNN layer. First one is 64 channels, and second stage two is 128 channels, and stage three is 256, stage four 500. Likewise, we are applying 4 conventional CNN layers to extract the data from two branches. And yeah, this is the main encoder logic which we did. And the third one is like cross-temporal processing and decoder. This is another important architecture. Like after both branches extract multi-skill features, this model compares them to identify what changed between T1 and T2. It has three sub-components. One is the cross attention at four scales. Another one is temporal difference, nothing but is defining the difference between T1 and T2. And another is feature fusion. Like cross attention at four scales means like the encoding logic from 68, 64, 128 to 56, 512 will actually pass this to this model to get the what actually we changed, and we then apply the changes difference, and we finally feature vision means we finally concatenation and into a single change map. This is how that full by after encoding we just merging into single change map, and then the same step will be applied for the decoder. Decoder is nothing but after encoding we just need to decode into the same previously. It will start from 512, 256, 128 and 64 channels. Each stage uses large kernel attention. Large content LKI means like each decoder block uses instead of standard small conventionals. Large kernels means each output pixel considers a wide neighborhood. This captures broad spatial attention and reconstructing the change map without any disturbance. So this is our full architecture about like data pre-processing, encoding, and feature, and finally the decoder. This is the full architecture which we develop using hybrid CNN and transformers. And this is final result which we get. These three are the old algorithms which we studied in our references, and our is achieving accuracy of 98% by comparing two data sets. And yeah, this is the output which we get. Here we can clearly see like this is the image T1 and image T2, and we can change like see like what has been changed, what are the buildings has been changed between two images. The green means like changed, black means like things.
Can you please conclude as soon as possible because time is up.
Yeah, yeah, sure. And this is the conclusion. Like finally, we built an hybrid CMS hybrid model to find the change between two time periods. And we use this like four models like multi-scale cross attention and decoders using CNN and transformers. Our future work is to detect multi-class detection and self-supervised fleet training. This is the thing which we developed.
So I have one question. What is the
Yeah.
application of this algorithm which you have developed?
Uh, can you repeat the question? It's not fully
What is
audible.
the like any real life applications where you can employ your development model development?
Mm. Yeah, like this change detection can mainly useful for like urban planners and researchers. They can see like real-time data between two time periods to identify what has been changed. So using this, we can figure out any urbanization or a decision-making process. It will be useful. Can apply for any research purpose.
Okay, so thank you for your presentation. So now
Yeah.
I request the paper ID 613 to present their work.
Okay. Yeah.
So I request the authors from paper ID 613 to present their work.
Good evening, sir.
Yeah, good evening.
So can I share my screen?
Yes, yes, please say.
Sir, is my screen visible, sir?
Yes, your screen is visible. So, yeah, you can please proceed.
So coming to my project title is multi-type fraud detection in e-commerce transactions using machine learning algorithms. And my name is Satvika and my guide is Pradeep Kumar, sir. And these are my teammates. And I am from Department of Information Technology from MLR Institute of Technology. And coming to the outline, in this project, I'll be explaining about introduction, objective, proposal system, design phase, implementation, results, and the conclusion. Coming to the introduction, to develop this project, the domain which we have used is machine learning. And coming to the problem statement, and these traditional e-commerce platforms are increasing vulnerable to multi-fraudulent activities. Due to the rapid growth of e-commerce platform, it has led to a significant increase in online transactions, which has also resulted in a rise in fraudulent activities. Due to this, there may be a significant loss in the financial losses for business, and they also may lead to the customer trust and reduce platform credibility. So therefore, there is a need for an intelligent and scalable fraud detection system that can accurately analyze the transaction and user behavioral data and identifying multiple types of fraud in real time, reducing false positives, and enhancing the overall security and reliability of the e-commerce platforms. Coming to the objectives, the main objective of this project to detect the fraudulent e-commerce transactions using the machine learning algorithms like XGBoost and Stacking Classifier, and it also helps to improve the transaction security by analyzing the customer and the payment patterns, and it also helps to reduce the financial losses caused by online fraud activities. It is used to compare different machine learning models for fraud detection accuracy, and it also helps to provide real-time prediction of suspicious transactions. It is used to minimize the false fraud alerts and improve the user experience. Coming to the proposed system, Multi-step fraud detection. It is used to detect different types of e-commerce fraud which occur through the payments it like such as payment fraud, refund fraud, identify theft, and account takeover. This payment may occur through the UPI or bank transfer or when a person makes an payment. And in this, we'll be using the advanced machine learning algorithms like XGBoost. In XGBoost, we will be constructing different number of decision trees. At each level, the decision tree at the decision tree which is constructed in the next level is used to reduce the error in the previous decision in the previous level. And coming to stacking classifier, in this stacking classifier we will be combining multiple algorithms together and which is used to improve the accuracy. And coming to data pre-processing and the feature engineering, it is used to perform the normalization and encode the data, and it is also used to extract the features of the important transaction features for better analysis. And coming to the behavior and transaction analysis, it is used to analyze the user behavior, and it is used to analyze the purchase history, device information, and the transaction patterns to identify suspicious activities. These data is used to identify whether the occurred transaction is fraud or not. And coming to the design phase, first we will be collecting the data in the form of the CSV files. Then we will be and next in the data pre-processing module, we will be cleaning the data, like we will be removing the unwanted data and we'll be reducing the size of the data. And next from that we'll be extracting the only the important features which helps us to detect the whether the occurred transaction is true or false. Next, coming to training and evaluation mode. Training and evaluation, from the features which we have collected from the data, we will be dividing it into the training model and the testing model. We will be dividing the 80% of the data for the training and 20% for the testing. And 20% and the testing is done on the unseen data. After by using 80% of data for training, then we'll be performing on the 20% of the data. Like we'll be checking whether the model is trained properly or not. For that, we'll be using stacking classifier or XGBoost. And coming to the implementation, first we'll be collecting the data in the form of the CSV files. Then we'll be pre-processing the data. Like we'll be dividing the data into the training data and the testing data. For the training data, we will be applying the algorithm. And the algorithm which we have applied is now implemented on the testing data so that the result is evaluated. And coming to the model will be given the inputs to predict the output. And the output is output is present in the user interface which is visible to the user. And coming to the results, here will become it is a accuracy comparison graph, and it is a comparison graph. Here we'll be comparing the accuracy, precision, recall, and the F1 score. Because we have used different types of algorithms like random forest, XGBoost, and stacking classifier. We will be using stacking classifier because it provides more accurate results. Coming to a conclusion, this improved fraud detection accuracy using machine learning, and we have used XGBoosting and stacking classifier for better prediction. We will be detecting multiple types of e-commerce fraud effectively, and will be reducing the false positives and improving the security. And we also provide a scalable and real-time fraud detection system. Thank you.
Thank you for your presentation. So I have two basic questions. One
Yes,
is
sir.
like from where you get this data on which you did this study.
So your voice is not audible.
Can you hear me?
Yes, sir.
So like what is the source of data? Like from where you get this data for study?
So we have collected the data from the cattle, sir.
Okay, okay. So Kaggle में basically the data are more polished. If you
Yes,
try to
sir.
detect actually on the actual raw data from the actual users, then you can uh, tune your research work more.
So your voice is not audible, sir.
Okay,
Yes, sir.
Is it audible now?
So your voice is low, sir. Yes, sir.
Is it audible now?
Yes, sir.
Okay. So the question we are asking is how you got this data.
So we have collected the data from the Kaggle, sir, in the CSV format.
And what
The
is
data consists of the user ID and the like which kind of payment he have done and the IP address of the data.
So how you can improve your study, because this Kaggle data are generally
So there is a disturbance from your side.
yes. Actually the Kaggle data are more polished. What I mean to say. So if you study on some real data of any e-commerce website, that will be more better.
Okay, sir, we'll work on, we'll try to implement in the other way, sir.
Okay, so thank you for your presentation.
Thank
I
you, sir.
request the next paper ID 618 to present their work.
Good afternoon, sir.
Yeah, good afternoon.
So, should I share my screen?
Yeah, yeah, please share your screen.
Sir, is my screen visible?
Yeah, yeah.
Yes, your screen is visible.
Hello.
Your screen is visible. Please proceed.
Yes, sir. Good afternoon, everyone. I'm Advaita from Department of Artificial Intelligence and Machine Learning from Vardhaman College of Engineering. So our project is titled Architecting Adaptive AI Call Assistants, Powerful AI Call Assistant to Automate Bookings, Support, and Business Inquiries. So our guide is Mr. Manish Chabra. So we'll quickly move to outline. So, this presentation covers the introduction, objectives, proposed system, design phase, implementation, results, and the conclusion. So, traditional customer support systems require human agents to answer customer calls continuously, which leads to the high operational cost, delayed responses, and limited availability. To solve this problem, we have developed an AI-powered voice assistant that can handle customer inquiries, bookings, and support requests automatically through real-time voice conversations. The project combines artificial intelligence, natural language processing, and speech technologies. So, our goal is to provide intelligent, scalable, and human-like customer support. So, the objectives of our project are like automate customer call handling, like enabling human-like voice interactions, which provides 24 by 7 customer support and improve the communication effectively. So then we move to our next proposed system. So our system consists of two major components, that is VAPI and Make.com, where this VAPI.ai handles the voice communication. It receives the customer calls, converts speech into text, and then converts AI responses back into speech. So Make.com automates the workflows. It collects all information, processes data, and stores record automatically, and the workflow goes like vapi.ai, then it goes to speech to text, then from text to speech the customer, and then make.automation, it stores the information in the Google Sheets. So this is our design phase, where the customer is received a call and the data is captured through webhooks, and the workflow then process the information and routes into different services. This eliminates manual data entry and improves the operational efficiency. This is the implementation where the customer interacts with the AI call assistant through a phone call. The call assistant accesses its knowledge base and processes the customer's request. Depending upon the user's requirement, it can answer questions or provide information or handle bookings. If a request becomes too complex, it can be escalated to a human agent. Here, the system combines automation with human support whenever required. So, this is the result. So where this is where vapi.ai, the conversation between the AI agent and the customer, the assistant successfully conducts real-time conversation and generates context aware responses. So the transcript panel demonstrate interactions between the customer and AI assistant. So here in this vapi.ai, we will give the prompting to the AI where it can answer the customer's questions. So this is the conclusion where the make.com and stores the information to in the form of Google Sheets like time to time, and it also stores the summary of the customer, and it automatically books the whatever the requirement the customer needs. So this is a conclusion where we have developed an AI-powered call assistant with no-code technology, and this is scalable for 24/7 business communication services, which we are mainly focusing on the small businesses.
So the
Yeah.
this meet.com and other one is like where it is hosted,
Sorry, sir.
where the
Web dot
meet.com,
Vapi.ai.
yeah, where these are hosted, on which how.
We can deploy it, sir. Like we can.
Okay, so is it deployed or it is not yet deployed? It is deployed.
Sir, it is under the process. We are almost deployed. We have to make few changes, and once it's done, it's ready to use. Or else, without deploying, also we can directly use through Vapi.ai.
Okay. So thank you for your presentation.
Yeah,
We
thank you,
can
sir.
move to the next participant, next paper ID which is 620. So I request the paper ID authors of 620 to present their work. Paper ID 620, authors of paper ID 620. Authors from paper ID 620, please present their work. Authors from paper ID 630, 630, are they present? Authors from paper ID 630, are they present in the call? Hello?
Hello.
So your paper ID is
647.
647. Okay, it's quite far away. Okay, so
Sir,
if you are ready,
634, can I present?
yeah, what is your paper ID?
634, sir.
6?
34. 634, sir.
Okay, yeah, you please present.
Okay, sir.
Yeah, you can share your presentation.
Sir, do slide visible.
Yeah, it is visible. You can proceed.
Good evening, sir.
Yeah,
Our title is Chronic Obstructive Pulmonary Disease Detection Using Machine Learning and Lung Sound Analysis. Our mentor is Mrs. Harshini, and these are my teammates. I am from IT department from MLRT Institution of Technology. Outline is introduction and problem statement, proposed system architecture, implementation and workflow, result and conclusion. Introduction: COPD is a respiratory disease causing airflow obstruction. It often goes undetected using advanced stages, limiting treatment options. Traditional diagnoses like spirometry, CT scans, which are expensive and not available in rural areas. So, global, it is at a top three disease of death rate, driven by smoking, air pollution, and occupational exposures. ML plus lung sound analysis offer non-invasive, low-cost early screening, and we uses MFCC algorithms and DBN algorithms, and we web-based application delivers remote prediction with confidence scores and proposed system. We collect lung sound. After collecting lung sound, we take it into pre-processing, which removes unwanted noise. After that, we uses two algorithms, MFCC, which is used for feature extraction, and DBN is used for classifying. Uh, DBN classify whether it has COPD or not. After that, we use doctor recommendation, preventive advice, health questionnaires, and awareness chatbot. And propose system ML-based web application for early COPD detection using lung sound analysis. Users record uploads wave lung sound in web interface. After that, we pre-process the data using which removes noise, normalization, and breathing cycle segmentation. After that, we use algorithms like MFCC, which encodes wheezes, crackles, and spectral patterns. After that, we classify that COPD present or not, using with confidence score. And implementations, we first use signal preprocessing, which provides removal normalization formula. After that, we use MFCC feature extraction with Fourier transform, mill filter banks, and log compression (DCT). After that, we will scale values m equal to 2595 into log of 10, 1 plus f of 700, which is model human authority preparation. And we use DBN classifier, which gives output using probability with supporting health chatbot and doctor recommendations. These are it is confusion matrix which shows values, and figure 6 shows output result showing the confidence value, result and performance. Confusion matrix gives 98.2 accuracy with system accuracy confidence scores of 95.8%, very low false negative rate, critical for medical screening applications. MSCC heatmap provides 2D visualization, shows temporal spectral repository features. Six respiratory classes tested: COPD, healthy bronchitis, pneumonia, and bronchiolitis. Conclusion: MSCC and DVN system achieves 98.2% accuracy in COPD detection. We provides low-cost, non-invasive, scalability alternative to traditional diagnosis. We provide web-based app enables remote screening with chatbot and doctor recommendations. In future, we use CNN and LSTM models, real-time mobile development, and clinic validations. Expanding training database for more diversity respiratory sound samples. Practical tool for rural healthcare and early respiratory disease management. Thank you.
So, have you consulted with any hospitals for validating your results?
Sir,
Have you like coordinated with any hospital for validating your results, or it is just from casual database?
from casual database, sir.
So, is there any future plan to validate it with the actual medical data from any hospital?
Yes, sir, we are working on it.
Thank you.
Oh, thank you.
So, thank you for your presentation.
Oh, thank you, sir.
So now we'll move to the next paper ID 620. Authors from paper ID 620, 630, 632, 636, 640,
Present, sir.
640.
Yes, sir.
So you please
Good
share your
evening, sir.
screen and you can start your presentation.
Okay, sir, I will. Mm.
Like MLR is
Visible?
visible. Yes, it is visible. So you can please start.
Okay. Oh, okay, sir. So, firstly, good evening. I'm Manasa, and today I'm here to present about my paper and the project named Yoga Sensei, Learning Based Platform for Tailored Yoga Session. So, firstly, in the title of the project, you can see Yoga Sensei. Actually, Sensei is a Japanese word which means teacher. So, our project aims to teach the I mean aims to guide the just a second. Our project aims to teach the yoga poses through a clear guidance. That's why we named it as Yoga Sensei. So coming to the outline that I'm going to cover, firstly I'm going to cover introduction uh, to a problem statement, and next objectives, architecture, results, and conclusion. So coming to introduction, like the the motivation behind our project, is like, we see today we have many yoga platforms and many other other things regarding yoga, but but most of them provide generic recommendations, like common recommendations irrespective of the problem. Like, that recommendation is not suitable to many of the people as they have other health issues. And again, like using our own knowledge, practice can be painful and stressful. So that's like, here we can see that practicing without trainer can lead to more physical injury. And with this with this with this our main problem statement is like providing personalization based on their some of their details, and guide them while doing the post, like bend, or like when they are doing a post, like we are instructing to stretch the leg a bit, or stretch the hands into a correct angle, like that. So our objectives are like, we are going to provide real time post correction in browser using webcam post detection, and we are going to show the safe and personalized yoga plan based on a rule based logic and machine learning. And here we are going to consider health constraints like injuries, their level of their level in doing yoga, and their age, and some other factors, etc. And here we are going to track their user sessions and comfort level, and we are going to show their progress in a slow manner, like based upon their performance on doing the post. So this is the system architecture. Based on the system architecture, these are the following modules. Like the modules are user interaction layer, that is we are going to collect user details like their health constraint, and like health problems, and their yoga focus area, and their goals, like whether they want to achieve flexibility, or whether they want to achieve some stretch, they want to get rid of the pain or stress relief, etc. And based on like, we are going to collect the details through the HTML page, and after we are going to process their details, and we are going to match the details with the yoga poses we collected. And based on the details, we are going to remove the unsafe poses, and using machine learning, we are going to we are going to view top 5 poses suitable for their profile. And like when they start doing, when they start doing the session, through computer, through media pipe, we are going to track their pose detection, and their their performance is updated using feedback. Like more the times they perform the pose, the more the accurate they become. So in this way, the module, like based on architecture, these five are the main modules: user interaction layer, data processing pipeline, machine learning engine, computer vision, and intelligent feedback loop. So coming to the results, like we used rule based algorithm and random forest machine learning algorithm for better accuracy and for better ranking of poses. So based on that, the the confusion matrix and feature importance snapshot is given here. If you see, feature 23 is of 12.1% and feature 13 is of 8.2%. So, and again, the model has achieved 83%, 93% classification accuracy using this random forest with a rule based algorithm. And based on, like, we can say that this is this is a different project which combines personalization and object, post detection together. And based on our research, we also found that, like uh, post detection is a different project, and personalization is also a different project. So with this project, we combined both individual features into a single unit. So based on this, I can conclude that with this based on the based on the user details, we can use rule based filtering, and we can do poses according to their profile. And one more thing, this replaces the generic based recommendation to, in a better manner, some to some extent. And this also bridges the gap and gives a better shows a better way to personalize and performing yoga in a better way. That's it. Thank you.
Okay. So whether you are going to classify the yoga poses, or how you what exactly?
uh, could you repeat, sir? I cannot, I
You
don't
are
understand.
classifying the yoga poses,
Mm. Or
or
uh,
how you are recommending? Like you said
uh,
about the conclusion, you are recommending. So how you are recommending the yoga?
like we are going to classify the poses according to the user given profile, sir. Based on the details matching, based on the, like we are going to take their injury list and their goals list, and based on that, we are going to classify the poses.
Okay, so let's say if a person don't have any injury, then
Hmm.
how you will suggest?
If a person
If a
like
person don't have any injury,
hmm.
so then how your system will proceed?
If a, so I'm like, I apologize, sir, but we didn't work in that point of view. We tried to work out, but it couldn't happen. So our motto was like to provide a recommendation based on their injuries and their based on their problems. So that is why we couldn't work out in that way, sir. but we but we tried implementing it, but it became a little bit complex. Mm.
Okay, so thank you for your presentation.
Thank you, sir.
Now we move to next. So paper ID 647.
Yes, yes.
Yeah, so you can share your screen and you can start the presentation.
యాక్చువల్లీ మేఘన నాకంటే జ్యోతి రాలేదు. నేను జాయిన్ అయినప్పుడు నడుస్తుంది. నాకు దాని తర్వాత ఇంకో ఇద్దరు ఉన్నారు చెప్పడానికి, వాళ్ళు ఎవరు రాలేదు. ఇంక అందుకే ముందే చెప్పేసిన.
సరే అయిందా?
అయిపోయింది.
So yeah, you can now present.
మరి అదే నువ్వు కూడా జాయిన్ అవ్వకపోతే
ఆ? ఒకవేళ నేను కూడా జాయిన్ అవ్వకుంటేను పోయేదేమో. లేకపోతే ఆ అమ్మాయి ఇప్పుడు చెప్తుంది కదా, ఆ అమ్మాయి తర్వాత
Good
నేను
afternoon,
చెప్పేస్తాను.
sir. My name is Nupur Kamri from Department of Computer Science and Engineering from Dattamegi
ఇంకొక ఆమె
Institute
చెప్తుంది,
of
ఆమె
Higher
పేరు రుతు.
Education and Research. Today, I am presenting my research work titled an empirical analysis of machine learning models for heart disease, heart failure prediction. Uh, Outline of the presentation is introduction, applications, methodology, advantages, limitations, result and discussion, conclusion and references. In introduction, this study focuses on the heart failure, which is a serious cardiovascular disease affecting millions of people globally. Heart failure occurs when the heart cannot pump sufficient blood to meet the body requirements. The early detection is extremely important because it can reduce the mortality rates and prevent the unnecessary hospitalization. Then machine learning techniques can analyze the patient health data and assist doctors in predicting heart failure at an early stages, enabling timely treatment and better health. Hello.
Yeah, can you make your slides full screen? Please make it the full screen. The fonts
Yes,
are not readable. Keep it in the
it's visible.
presentation. Keep it in the presentation mode. Make it full screen. Make the presentation full screen. Press F5.
The machine learning techniques can analyze the patient health data and assist the doctors in predicting the heart failure at an early stage, enabling the timely treatment and better healthcare outcomes.
अरे नीचे है तो आइकन.
Coming to applications, the purpose system has several predicates. Application first, clinical decision support. It helps the doctor in early diagnosis and treatment planning by the identifying the high risk patients. Second, early disease detection. It predicts the heart failure risk before the symptoms become severe, allowing the timely medical intervention. And third is hospital management. It assists in predicting uh, patient readmission risk and help the hospital allocate the healthcare resource efficiently. Remote patient monitoring. In the system, the can be integrated with the wearable devices and IoT sensors to provide continuous health monitoring. In methodology, the purpose
framework follow a complete machine learning pipeline. The process being the with the data collection where the clinical patient data is gathered. Next is the data pre-processing to clean and prepare the data set. After the future encoding is uh, applied to convert the categorical data into numerical form to handle the class imbalance. uh, ADA, ADA by S Y N sampling is used. The data set is then divided into the training and testing sets using the trained set split, and various machine learning models are trained and used for the predictions. Finally, perform it is evaluated using the standard materials such as the accuracy, precision, recall, and F1 score. In advantages, the purpose of approach the offered the several advantages. First, early detection of the heart failure. It identifies the high risk patient early, enable the timely medical treatment, and second, the high precision accuracy gradient boost, achieve an accuracy of 92.45%, uh, provides the reliable and accurate predictions, demonstrate reliable performance. Third is improved clinical decision making. It support the doctors in a diagnosis and evidence based treatment planning. Efficient in handles imbalanced data effectively. In this, the ADA by SYN improves the model performance by the balancing the minority and majority classes. In limitation, the first is a dependence on the dataset quality. The model performance depends heavily on the quality and completeness of the patient data. Limited data size. The model was trained on a publicly available dataset with a limited number of the records. Performance may vary on a large real world datasets. Uh, Generalized issues, in this the model trained on one dataset may not perform equally well across the different hospital or populations. In a lack of explainability, in this the advanced models like gradient boost and MLP make acts as a black box models and making it difficult for the doctors to understand prediction and reasoning. Coming to result and discussion, in this phase, the different machine learning models were evaluated using accuracy and precision recall and F1 score. The result indicated that ensemble the learning methods the performed better than the other algorithms among all models. Gradient boost achieves the high accuracy of 92.45%. Random forest achieved the 90.12%. MLP achieved the 89.33%. They additionally labeled encoding ADA, SYN, and across the validation significantly improved the prediction accuracy and reliability. Overall, the uh, purpose the approach outperformed many previous studies and demonstrated effectiveness in heart failure prediction. In conclusion,
To conclude, this study compared various machine learning and deep learning models for the heart failure prediction. The findings show that the gradient boosting delivered the best performance with an accuracy 92.45%. Data pre-processing techniques such as label encoding and ADA SYN plays an important role in improving model performance, and therefore the purpose system provides the accuracy and reliable failure prediction, and can be used as a valuable tool for the clinical decision support and early disease detection. Thank you.
So, Nupur, how your system is predicting the heart failure early detection? Like what
In
factor exactly it takes?
In this model, sir, first of all the add all medical parameters like bp, sugar, uh, cholesterol, age. All these things are important to check the heart disease.
Okay. So, from where you get all those parameters for training your model?
Sir, in this I am collecting this data from the our hospital in DMIHR, Savangi.
So, okay, ठीक है. So now thank you for your presentation because of time limitations we have to go. So thank you
Okay,
Nupur for your presentation. We'll move to the next.
thank you.
So now, Mayank, what is your paper ID?
Yeah, sir. My paper ID is 657.
657. Anyone else is present? तीन दिख रहा है. So you can share your screen and
Yeah,
you can present.
yeah. We can start. Okay. So I'm sharing my screen. Okay. So I hope so. My screen is visible.
Yeah, make it full screen.
Make it full screen.
Yeah. I am full screen. Okay. So I think my screen is visible to you.
Yes, it is visible.
Okay. So good evening all. I Dr. Mayank Lowanshi, currently working as an assistant professor at Bennett University, and my paper ID is 657. That the title is an attention-based multimodal AI system for precision agriculture. So, yeah. So this is my outline that contains the introduction, contribution, methodology, data set, what we had explored. Then after that, the experiment and result. Then we are concluding this thing. So now if we are talking about the introduction, so everyone, as we all know that the agriculture is backbone of our system, where the paddy or we can say the rice is the primary food for us, as the 50% of the world population are eating that particular thing. So we need to check or we need to find out its prediction is that we need to get the more yield of that particular thing. So sustainability of the paddy production is the essential thing that we need to maintain. So this is the important thing that we need to focus on. So there are some of the challenges whenever we are doing the paddy farming. So it is containing some of the crop disease. So this can reduce the yield as well as the productivity of that particular thing. We are also making or we are that one issue is also there that the inefficient fertilizer thing is there, that the inaccurate estimation of the yield is there, we don't know about the harvesting cost. So these all are the challenges where we are going at the field and we are detecting the manually we are detecting the disease. So this is the time consuming and the less accurate technique. So we are taken that particular things into the consideration, and we had make a one AI or ML or deep learning related model that can solve such kind of problems. So the CNN model is helping in that particular things. So there are lots of existing model is already present, just like a ML deep learning kind of things. So that things we had already completed. So what is our novelty? Our novelty is that we had collected the data. So during my PhD time, we had collected the one paddy data at the Chhattisgarh. Okay, so where all the people are doing the crop of paddy. So we had collected the many diseases, just like paddy is having the these six diseases, these five diseases. That is the bacterial leaf blight, brown spot, leaf blast, false smooth, as well as the seed blight disease. So this is there. So these are the research gave that in the existing the disease detection, yield production, as well as the fertilizer estimation. So this is the one of the research gap is there. Now the integration problem is there. There are lots of images there, structured agriculture thing is there. So the integration is the biggest issue, as well as one more research gap is there, where we cannot determine the crop health and the soil condition, what are the harvesting cost we are requiring. So these all are the challenges that we had already happened. So for this we had made the multimodal kind of solution, where we are integrating the AI based kind of thing. So where the we can detect the paddy disease, then we can estimate the harvest cost. So here we had used the attention based deep learning model, where we are using the one transfer learning, where the BGG 16 as well as the BGG 19 model we had used. After that we are also fusing the multi-head attention with this, so that we can enhance the accuracy, as well as we can make a more complex feature we can extract from that particular things. So the third novelty that are the main novelty of our paper, that we had find out the real field paddy data set. So this is the multiple disease categories there, different environmental conditions, image we are having. So it is having the lots of things in our data set. So what methodology we had followed? So we had collected the data. So we had collected the real data in the field, where we are also identifying the what are the soil fertility is there, what are the fertilizer uses is there. Then after the collection of the data, we had used the image pre-processing, where we had identified how we can enhance the image quality while removing the noise and unwanted artifact. So these all things we had done. So we had convert our RGB image into the HSV image, so that we can extract the local binary pattern. So this is the pre-processing kind of things. Then as we can see in the right hand side in the figure number 1, we had collected the data. After that we are applying the pre-processing. In the pre-processing we are removing the background, as well as we are converting our RGB into the lab, that is the lightness and the different kind of color combination we had done. After that we had putting the multi-head attention feature, which will give the more attention to that particular feature that are really important for us. Then we had applied the BGG 16 and BGG 19. So we had used the two model, just like the first one is the multi-headed attention, that we can also called as the transformer. Then after that the BGG 16 and 19 data we had used. Then from that we had calculated the accuracy, precision and recall. Then again we are putting the same model again, that is the BGG 16 and 19, for checking the more accuracy. So we had again doing this particular things. Then we had applied the multi-head attention feature over the two images. One is without the pre-processed and one is with the processed image. So then we are getting the accuracy and precision, recall, everything. Then we are comparing. Then at the end we are applying the ensemble learning. Then through the majority voting we had identified what kind of disease is there. So our main task is to identifying the what kind of disease is there. So this is our methodology and this is the data set we had used. So this all are the six type of the data set categories there. One is the healthy, while the five other are the disease that are present in our data set. So in our data set there is a around 45 images there that we had collected for the accurate disease. So the data set we present is real agriculture field condition. It is also collecting the conditions also. It can design for improving the robustness, and we need to do that particular thing. So after applying all the deep learning model, we had identified these six classes. Out of this, one of the classes are coming after the ensemble. Then we are identifying this particular thing. So before, yeah. So now next is the experiment and result. So we had done the BGG 16 as well as the BGG 19. Then also we are added the attention. So whenever we are added the attention, then we can see the combination of the BGG 19 with the attention are giving the good result. We had not comparing our result with the existing model because our data set is our novelty that we had not that particular the data set is as per our knowledge that particular data set is with me only and with my supervisor only, so nobody had done that particular things or the many paper are not work or many model are not worked on our data set. That's why we had not compared that particular things. So we had done the some evaluation study kind of things. So whenever we are doing the pre-processed image with the BGG 19, then we are applying the attention, then we are
Mayank,
getting, yes,
like
yes,
time, you have to conclude in
yes,
one
sir,
minute.
yes, yes, sir, okay, okay. So we are getting the 96% accuracy. So now I am concluding this particular thing. So whenever we are using the AI based kind of things, we can accurately develop that petty disease and we can efficiently make the crop management. So as we can say through the result that BGG 16 and BGG 19 and the multi-head attention. So whenever we are performing these particular things, we are getting the 96% precision. So precision is important in that particular aspect. So we had also made that particular things for the economically decision making and all kind of things. So this is helpful for that particular concept also. Now the future work is that we need to put the some of the IoT sensor and we need to identify and we are creating the mobile application and we can also extend this particular work with the multiple crop. So this is our future work. So that's it from my side. These are references. So these are the thank you. Yes,
Okay,
sir.
thank you, Mayank, for your presentation. So,
Yes, sir.
thank you. Like time is up, so we'll
Oh,
move to the next
oh,
paper ID. Yeah.
okay, okay, okay. Thank you, sir. Thank you so much.
So, Savannah, what is your paper ID?
636, sir.
Okay, so you can start your presentation by sharing the screen.
Okay, sir. Good afternoon, everyone. I am Shravanti from MLR Institute of Technology. Today I am going to present our paper titled Anomaly Detection in Network Traffic Using Advanced ML Techniques, a Self-Supervised Contrastive Learning Framework. So let's begin. In this presentation, I will explain the problem statement, key contributions, proposed architecture, methodology, experimental setup, results, conclusion, and future work. So, coming to the problem statement, the challenges in the existing intrusion detection systems are they produce many false alarms and they mainly depend on labeled attack data. So, they also struggle to detect new or unknown attacks. So, to solve these problems, we developed a self supervised framework. It learns how normal network behaves without using any labeled attack data. And also, in the existing systems, it has a poor adaptability to evolve and unknown cyber threats. The motivation for this is we identify suspicious activities without requiring any labeled attack data. And it also addresses real world deployment in cloud and IoT environments. So, coming to key contributions, our work has five main contributions. First, we use a dual autoencoder. It learns temporal and content features separately. And the second one is the model is trained only on the normal network traffic. Third one is it reduces the false positives and it improves the precisions from 0.65 to 0.912. The fourth one is it also detects the unknown or zero-day attacks without using labeled examples. Fifth one is the contrastive learning helps create a better separation between the normal and abnormal traffic. So, our proposed architecture. First, the network traffic data is collected and pre-processed during the pre-processing. We clean the data and handle missing values and normalize the features. Second, the pre-processed data is passed to dual branch autoencoder framework, that is temporal autoencoder and content autoencoder. One branch mainly focuses on learning temporal patterns, which means it captures how network traffic changes over the time. The other branch focuses on the content features. It captures the characteristics of the network packets and connections. Next, both the autoencoders generate a latent representation. This indicates compact metavectors. It contains important information about the traffic. We then apply the contrastive learning. It helps the model to learn a better distinction between the normal and abnormal traffic. The each autoencoder reconstructs the input data and produces a reconstruction error. Since the model is trained only on the network traffic, it can reconstruct the normal samples well, so it results in low error. But if abnormal traffic is produced, it constructs the reconstruction error will be higher. So finally, the reconstruction error from the both the encoders is combined and calculated, uh, and it calculates the anomaly score. If the score exceeds the threshold, then the traffic is classified as anomaly. Otherwise, it is classified as normal. In this way, the dual branch architecture and contrastive learning works together to improve the anomaly detection performance. Coming to methodology, our framework uses self-supervised learning. It uses two autoencoders. Each model will learn the normal traffic and try to reconstruct the input, and it enables the detection of anomalies as deviation from learned normal behavior. And the second is contrastive learning enhancement. Here it applies the contrastive laws to structure the latent space. What it does is it pulls the normal behavior closer and it pushes the anomaly behavior patterns up far. So this helps in improving the zero-day attack detection capability and unified anomaly scoring. Here, what it does is it combines the both the reconstruction errors from the two autoencoders and it generates a unified anomaly score for the final classification so that it can reduce the false positives. Continuous adaptation. So here we continuously update both the models using the fresh network data so that it can adapt to the evolving cybersecurity threats and changing network environments. Experimental setup. For our experiment, we use the UNSW MD15 dataset. It contains more than 257,000 network traffic records. It contains both normal and attack samples, and it has 193 features in it. We implemented this framework using the PyTorch and evaluated it using the precision recall, litmus score, AUROC, and AUPRC. Coming to the results and performance comparison, uh, our proposed framework achieved a precision of 0.912
Savannah, the slides are
and
not
measurement
changing.
score of 0.
The slides are not changing.
What, sir?
Can you? The slides are not changing. So can you check like reshare?
Yes, sir. Yes, sir. Can you see, sir?
Yes, yes. Now it's visible. So
Mm.
please complete in 2 minutes.
So, okay, sir. So, compared to other models, it produced fewer false positives and better overall performance. And graphs. This slide shows the precision recall curve and ROC curve. Here, precision recall curve shows the strong detection performance, and ROC curve has a AUC value of about 0.893. It indicates good classification. And coming to conclusion, to conclude, we proposed a dual branch self supervised anomaly detection framework. It learns the normal network behavior without needing any labeled attack data. By combining the autoencoders and contrastive learning, the model achieves better detection performance and fewer false alarms. So this it outperforms single autoencoder and dual autoencoder baselines with significantly fewer false positives. These results show that our approaches are effective for modern cybersecurity applications. In the future, we plan to deploy the model in the real-time network environments. We also plan to improve the adaptive thresholding and reduce the model size for edge devices and test on larger data sets and also integrate this framework with the security monitoring system. Thanks. Done, sir.
So Savannah, what applications you are targeting?
What, sir?
What applications you are targeting? Like where you will detect the anomaly in real world?
In real world, it can be applied in various cybersecurity environments, like where we can detect abnormal network behavior. Some applications like in cloud or data centers or IoT networks, we can use it. So,
Okay, 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 Savannah. So thank you for your presentation. Now
thank
we'll
you, sir.
move to the next. So Nikhil, what is your paper ID?
659, sir.
So you can start your presentation. Share your screen and you can
Okay,
start your
sir. Thank
presentation.
you. Okay, sir. Thank you, sir. Good afternoon, sir. My name is Kottapalli Nikhil from ML Law Institute of Technology. Today I am presenting our research work titled AI Driven Detection of Distraction Driving is one of the major causes of road accidents while sir. So activities such as texting, like having phone call and eating or looking away from the road, significantly reduce the driver attention and response time. So to address this problem, we propose a hybrid CNN transformer based on deep learning to tackle this problem. Okay, sir. One 1 minute, sir. It's not moving. I'm sorry, sir. 1 minute. Sir,
Yes, yes, Nikhil. Can you please
sir, I
resume?
are you able to see my screen?
Yeah, we can
Still,
see the screen. Yeah, yeah.
thank you,
Please
sir.
share the slides.
Yes, sir. Sir, before discussing
Yeah.
the proposed solution, let me briefly outline the.
Please make it full screen.
Okay, sir. Yes, sir. Sir, I will explain the problem statement, objectives of our full screen. Okay, sir. Yes, sir.
Yeah. Now please
And
continue.
I will explain the problem of the distracted driving and the objectives of our research work. Then I will present the proposed hybrid CNN transformer and the methodology used for the implementation. After that, I will conclude. Yes, sir. Okay, sir. Distracted driving is one of the leading cause of road accidents worldwide, sir. Driver often engage in activities such as texting, making phone call, eating, drinking, looking away from the road, which significantly reduce their attention and reaction time. Traditional monitoring systems are often slow, inconsistent, and they are very unable to detect the distraction accurately in real time. The response time is very important. The faster we detect and report the distraction, it better it prevents the accident. So although some of the deep learning approaches have improved the detection performance, but many are still suffer from the limitations such as overfitting and poor generalization under various driving conditions. So therefore there is a need for an intelligent, reliable system that can accurately detect the driver distraction. So we are proposing hybrid CNN transformers, sir. So when it comes to objectives, the first objective is to develop a system capable of accurately detecting the distracted driver behaviors, such as I already said, like testing and like that while driving. And the second one was to combine the CNN, like convolutional neural network and vision transformer, to improve the classification performance. So the third objective was to ensure reliable detection under various driving conditions. And the main ultimate objective is to improve road safety through accurate distraction detections. And our proposed hybrid framework. In this, it includes data acquisition, frame extraction, and pre-processing, and hybrid CNN transformer phase, and classification, then evaluation, sir. So when it comes to methodology, this slide explains the implementation of methodology followed in our research. So first, driver images and video datasets are contained, which contain the different distraction activities were collected, and next frames are extracted and pre-processed using resizing, like resizing into 224 into 224, and normalization and data augmentation, like copying and brightness adjustments and constant, to make it different environment conditions, so that it can model can learn and adapt to different type of uh, environment conditions. Then use of the hybrid scene and transformer model to extract the spatial features and uh, convolutional features. Then it passed to the dense layer and softmax layer to classify diver behavior and train the hybrid CNN transform model using distraction datasets. At the end, uh, the model is evaluated using classification metrics and like accuracy, precision, and recall and F1 score metrics. And this slide illustrates the algorithms which are used in our research. First, the CNN extract the important spatial features from driver images, and the next, the vision transformer capture the global contextual relationship through attention mechanism. Like it tells which regions are more important from the image and how they are related to each other. And dense layer, it learns a complex instructions from the extracted features, and softmax converts the output probabilities for the prediction, like it's the final output it will give. And the final one is multi-head attention allows the model to focus on multiple important regions simultaneously. And results and explainability, sir. In this the slide explains the explainability aspect of attention-based models. In hybrid CNN transformer architecture, the attention mechanism helps to identify the most relevant regions of an image when making the predictions. The highlighted, here you can see that, sir. The highlighted red and yellow uh, identifies the distracted regions. So the attention mechanism detects these distracted regions and helps to uh, make a relationship between those regions. And the highlighted regions are represent the areas that higher attention from the model, such as driver's hands, face, and mobile phone and gaze direction. This visualization helps to understand the why distraction activities such as texting, phone call, and looking away are classified as distracted behaviors. While our primary experimental evaluation focused on classification metrics, this illustration is demonstrates how the attention-based architecture can improve model interpretability. And the output slide. This slide presents the performance of the proposed hybrid CNN transformer activities. Experimental evaluation showed a strong classification performance with accuracy of 97, like that, and precision also 97 percentage, and recall and 98, like F1 codes are 96, like that. When compared with the baseline approaches such as simple CNN, VGG16, and VGG19, the hybrid CNN transformer achieved a superior performance across all evaluation metrics. These results demonstrate the effectiveness of combining simple CNN with a vision transformer to improve the classification. And in conclusion, this research proposed a hybrid CNN transformer framework for distracted driver detection. By combining CNN-based spatial features extraction with transformer-based contextual learning, the system can able to effectively identify multiple distraction activities. The model achieved a strong performance of accuracy 9 point, yeah, 9 point, like 98 percentage, like that. So demonstrating the effectiveness of proposed approach. In future, this work can be extended to include the uh, low price devices like Raspberry Pi and just a nano. It can be implemented in the devices, and it can implemented in the cars which don't have advanced alarming, like advanced driver detection systems. So this is for my answer. Thank you.
So, Nikhil, like, have you tested your development in real scenario, like for any real driver?
No, sir. No, sir. No, sir. No, sir. It's primarily is an experimental perspective. I did in collab. Using I developed the model and tried using straight from data set, and I compared with the baseline approaches like CNN and VG16 and VG19.
Are you planning to do it in the future, like actually putting a camera and capturing the
Yes,
images
sir.
and then analyzing the
Yes,
images?
sir. Yes, sir. Yes, sir. Yes, sir. I wanted to do in Raspberry Pi, but because of it's not available in our college CIE, so I didn't do that. But I will do that, sir.
Okay, Nikhil. So thank you for your presentation.
Thank you, sir.
Yeah, thank you.
May I leave, sir?
Yes, yes.
Thank you, sir.
We have seen. नहीं, चलो। वो फोटो की जाएगी। कोई नहीं आया बल्कि। आप कहाँ से हैं? हाँ, अच्छा। ये इलेक्ट्रिकल डिपार्टमेंट। सौरभ के साथ हैं। सौरभ कौन? सौरभ सौरभ जो ये बताया ना उसमें। अच्छा सर। हाँ, मैं मुंबई से कर रहा हूँ। आप? मैं उसके साथ नहीं हूँ, बट दूसरी लैब पर हूँ। अच्छा, इसमें मैं अथॉरिटी लैब कर रहा हूँ। सब कुछ है। ये सही पे करना है। इसका मैं क्या करें? प्रेस कर दिया मैंने। आप देखो तो ये नहीं आया आपसे। अभी तो कोई आएगा नहीं। यहाँ पे आ रहे हैं क्या कोई फोटो खींचने? बोल तो रहे हैं। ये सब क्या है? यही तो सर्टिफिकेट है। अच्छा, ये सर्टिफिकेट हम लोग का है? हाँ, ये देना होता है लास्ट में। तो वो किसी को बुलाएंगे तो ऐसे है। अच्छा। अभी कोई आया नहीं, बाकी 3 लोग एब्सेंट हैं। सर्टिफिकेट दे देते हैं। आप फोटो खींच लिया? सर,
5. Stop streaming. Stop streaming.